students, welcome back. This is Torres. Elbow bump. How are you? Are you doing okay? How is your family? Are they okay? Remember, if you need anything, please shoot me an email so that I can try to help in some way. So lucky you, you get to hear my voice for another lecture. But the best part is we will be describing scatterplots. Yay! Let's start by defining a scatterplot. So a scatterplot is just a graph of a collection of ordered pairs. The graph looks like a bunch of dots, but some graphs have a general shape or they will move in a general direction. The independent and dependent variables can be plotted on the graph called a scatterplot. The independent variable is plotted on the horizontal x-axis, and the dependent variable is plotted on the vertical y-axis. When describing scatterplots, we want to include three things: the shape, the trend, and the strength. Let's talk about each one of these individually. Scatterplots can come in all kinds of shapes. As you can see, we've got some crazy ones right around here. These are not linear. These are forming some level of relationship between the independent and dependent variable, but it's not a linear relationship. In this class, we're only going to discuss scatterplots that have a linear shape. So the easy thing about this class is that every time I ask you what the shape is of a scatterplot, you can always just say linear. Here we see an example of a linear scatterplot where these dots seem to be creating a line. Let's talk about trends next. So I'm going to show you some scatterplots, and some of these we're going to call examples of a yes, and some of these we're going to call examples of a no. As I show you the examples, I want you to look for a pattern to identify the rule for what makes a scatterplot a yes or what makes a scatterplot a no. Okay, so let's see how we do. So here's my graph where I'm going to be putting all the yeses and all the nos. So let's look at our first scatterplot. So here's our scatterplot, and I'm going to tell you that this is an example of a yes. So I'm going to put that scatterplot in the yes column. Okay, so take a look. This is a yes. Think to yourself, what are the characteristics of this scatterplot that make it a yes? Let's look at another one. Here is another scatterplot. I'm going to tell you that this is also an example of a yes. So I'm going to go ahead and put that scatterplot in the yes column. Here's another scatterplot. Think to yourself, is this a yes or is this a no? I'm going to go ahead and tell you that this is another example of a yes. So it's going to go in the yes column again. Let's look at the next one. So take a look at this example and think to yourself, is this going to go in the yes column or is this going to go in the no column? I'm going to tell you that this is an example of a yes. So this is going to go in the yes column. Okay? Let's look at this one. Think to yourself, which column is that going to go in? Well, this is an example of a no. It's going to go in this column. So let's just take a look at my yeses and nos. This is a yes, this is a yes, this is a yes, this is a yes. And think to yourself, what do all these things have in common where it's different than what's happening here? Here's another example. I want you to think to yourself, is this going to be a yes or is this going to be a no? This is a yes. So it's going to go in the yes column. Let's look at this one. Does this look like a yes or does this look like a no? Think about the characteristics that you've noticed between the two columns. So this is a no. It would go here. So what does this show? This shows that these have a trend. This has a definite pattern. As we increase on the x-axis, this one seems to increase on the y-axis. And for this one, as we increase on the x-axis, this seems to decrease on the y-axis. We definitely can spot that these are linear relationships, right? We're starting to see a line. Whereas this one, there doesn't seem to be a line at all. It's very blown out. All the dots are just truly scattered, where it's not even forming any sort of shape. So this is a description of trends. Sometimes you'll have a positive trend, sometimes you'll have a negative trend, and sometimes you will have no trend. So let's talk about trends in a little bit more detail. So here is a scatter plot, and on the x-axis, which is our independent variable, we have age, and on the y-axis, which is the dependent variable, we have miles. And this is a scatter plot showing the relationship between the age of a car and how many miles are on that car. So here we see that if we're looking at the ordered pairs that have created this scatter plot, as the values increase on the x-axis, they are also increasing on the y-axis. So the result is something that resembles a positive line, right? We just talked about that yesterday when we did the video on the review of the equation of a line, and we talked about the trend of the line. Here we're showing that the relationship is positive, okay? So there is a positive association or a positive relationship between how old a car is and how many miles it has. Here is another scatter plot. And this is showing that literacy rate, how many people can read, is the independent variable, and the dependent variable is looking at how many births a woman has had. Okay, and this is looking at women from various countries. As the values increase on the x-axis, the values decrease on the y-axis. So when they increase on the x-axis, or the independent variable, they decrease on the y-axis, or the dependent variable, we see that this starts to resemble a negative line. This would be considered a negative association. So we can say that there's a negative association between literacy rate and births per woman. There are times where there is no trend. So it doesn't seem to be any association. This thing just kind of looks like a big blob with random things. It doesn't seem to increase. It doesn't seem to decrease. It just looks like a bunch of just randomly scattered points. In this situation, it is comparing the age someone is versus the time it takes for them to complete a marathon. And according to this data, as age increases, it doesn't seem to have any association with how long it takes them, right? So here's our independent variable, which is age, and the dependent variable, which is time. So there seems to be no association or relationship between someone's age and the time it takes for them to complete a marathon. So when you're looking at a scatter plot, you already know that the shape is going to be linear. And if it's linear, it's either going to have a positive trend, a negative trend, or no trend. So going back here, we see that this is a positive trend, this is a positive trend, this is a positive trend. This one decreases over as the x values increase, the y values decrease. So this is a negative association. And this last one seems to also be a negative association. These do not appear to have a trend. The final characteristic we will discuss is the strength of an association. If for each value of x, there is a small spread of y values, this is a strong association between the x and the y values. If for each of the x there is a large spread of y values, then there is a weak or there is no association between x and y. If there is a strong association between x and y, then x is a good predictor of y. The opposite is also true. If there is a weak association between x and y, then x is not a good predictor of y. There is a value that you can use technology to calculate called a correlation coefficient. And a correlation coefficient measures the strength between two variables for a linear relationship. The correlation coefficient does not have units, and it will range between -1 and +1. The closer the correlation coefficient is to -1, the stronger the negative linear relationship. The closer the correlation coefficient is to +1, the stronger the positive linear relationship. If the correlation coefficient is close to 0, then there will be either a weak relationship or no relationship between the two. The correlation coefficient is described with the lowercase r. Let's look at some examples. Now here in the first row, you can see that these first two are negative relationships. We can see that these points are trending downwards, right? As x increases, y decreases here. And that these points are very, very, very close to this line that has been created. Because they are so aligned, this correlation coefficient would be a -1. Now you don't calculate this, it's calculated for you. I mean, you could calculate it, but it's really tedious. You don't want to calculate it, trust me. So what this is saying is that this is a perfect correlation coefficient, that this is forming a near close to perfect line. So it's a very strong relationship. It's almost completely linear. So here is another negative trend, right? And we decided ahead of time that all our scatter plots, we're just going to assume that they're linear. So here is a trend that is trending downwards, and this has a correlation coefficient of negative, because it's a negative trend, 0.6. This has less strength than something like this one because the points are not on the line. They're scattered around it. Okay? Approximately half of the points are above that line and approximately half of the points are below that line. So here it's a little bit spread out, and although this is still a negative trend, the strength is weaker than something where all the points are right on the line. In this example, we see that there's no association, right? It's like we have a zero slope line. There's half the points, approximately half the points are above and approximately half the points are below. And this is showing that there's no relationship. And the correlation coefficient shows that there is no relationship also because it's saying it's 0. Here, the same thing is happening, but in reverse. Here, we have a positive trend, and all the points are aligned almost perfectly. So we can say that the correlation coefficient is +1. It's a very, very strong relationship between the x variable and the y variable. Or we can say it's a very strong relationship between the independent variable and the dependent variable. Let's look at this one right here. Here we can see that the points are more blown out. They're further away from this line. Okay? It's still positive. It's almost hard to see, right? Because it's so blown out that you could almost wonder if that's just no association. When things get this blown out, you need the correlation coefficient to actually tell you there is a relationship here. It's weak. It's only +0.3, but there is enough to say that there is a weak relationship. Now this one is again no relationship. So here we have all the points are on a zero slope type of line. So there would be no relationship. So we can say that there is no relationship between the independent variable and the dependent variable. So again, this is very strong relationship in the negative trend. This is a moderate relationship in the negative trend. This is no relationship. This is no relationship. This is a weak relationship in a positive trend. And this is a very strong relationship in the positive trend. So you can see how relationships and trends describe two different things. Here is another example. When we have a strong relationship, there isn't a whole lot of spread here. It's very closely packed. This is a positive, strong relationship. Here, the opposite is true. These points are closely packed, right? They're close to one another. There's not that much of a spread, but this is trending in a negative direction. Here, we have a weak relationship that's trending in the positive direction, and we can see that the points are spread out, right? They're starting to blow out. Here we have a negative trend, and again, we're seeing that sort of blown out association. Same thing is happening with no relationship. With no relationship, it can't really even be weak or strong. It's just no relationship. Now, as I said, the correlation coefficient is calculated for you. You will not have to calculate it yourself in this class. And you will usually see it in terms of just output. So here we have the correlation coefficient is 0.9. And we can say that there is a strong relationship between age and blood pressure. They had a scatterplot that on the x-axis, it had age, and age was the independent variable, and on the y-axis, they had blood pressure. Blood pressure was the dependent variable. They plotted their points, and the computer was able to give them the correlation coefficient of 0.9. So because 0.9 is positive, we can say that it's a positive trend. We already know it's linear because we only work with linear shapes here. And we can say that it's a very strong relationship because 0.9 is very close to 1. So to summarize, when you are describing or analyzing a scatterplot, you want to look for three things. First, you want to look for the shape of the trend. For our class, we're just going to be working with linear shapes. Next, you want to see if there is a trend. If you see a trend, it should be either a positive trend, where it seems to create a line that is increasing, or a negative trend, one that is decreasing, or if you cannot determine if there is an association. Next, you want to try to determine the strength of the trend. Is the association strong, where all the points seem to be close to one another and close to creating this sort of line? Or is it blown out and very weak? If you have been given the correlation coefficient, you can also look at that number to see if it's positive or negative, to confirm on whether you have a positive or negative trend. And you can also check to see how close the number is to positive or negative 1. If you have a positive correlation coefficient, the closer that number is to positive 1, the stronger the relationship. If you have a negative correlation coefficient, and the closer that is to negative 1, the stronger the relationship. The closer the correlation coefficient is to 0, the weaker the relationship. So let's look at an example here. Here's a scatterplot that is comparing the median age of marriage for women as the independent variable versus the dependent variable median age of marriage for men. What we can say is that a scatterplot was created to compare the median age of marriage for women versus the median age of marriage for men. Okay, so the first sentence just has what the scatterplot is trying to compare. The scatterplot shows that there is a positive, strong, linear relationship between the independent variable median age of marriage for women and the dependent variable median age of marriage for men. So here we have the trend, the strength, and the shape. Okay? These don't have to go in any particular order. Whatever you prefer and makes sense for your sentence is how you should proceed. So what's the big idea? Today's big idea is that a scatterplot is one method used to investigate relationships between independent and dependent variables. When you are describing a scatterplot, you should include its shape, its trend, and its strength. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay, this is your teacher Taurus saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!